Hi, welcome to this session. We're going to talk about data visualization using SVG. My name is Rudy Mortier. I've been a developer in 4D for I think almost 30 years now. So I've been there, done that on some occasions. SVG, what and why? Is anybody here is not familiar with SVG? Nobody? Good. Well, that helps a lot. So what? It's short for Scalable Vector Graphics. On the internet, it's kind of a standard de facto. It's used in a lot of situations, especially in rendering web pages with charts or graphs or things like that. Important to know is it's XML based. And it's small file size, which kind of helps a little bit when moving it around in 4D or opening it or saving it. So why? Maybe a few of you remembered what was called 4D Draw, which was actually a drawing solution inside 4D, which allowed you to do a lot of things and to control it from 4D and to control it from code, so that was kind of interesting. But I think coming version 11, they introduced SVG inside of 4D, which is actually a good thing, and the only thing that lets you control everything in the drawing exactly as you would like it to, and it allows you a lot more control than what, for instance, you would be able to do in standard forms that are provided by 4D. The most interesting part, and you're going to see that later on in the demo, is the ability to actually interact with the things that are displayed on the screen. Be it a map, be it a chart, be it actually whatever you want to draw in the SVG, you can interact with it and you can control it. Also, very nice to know it's that in the SVG it's basically a picture, because that's how 4D deals with it, but besides the picture it's also vector based, so it means that you don't have actually dots, you don't have things that look like a paint application on Mac or on Windows, where you actually have one resolution and that's it. It's not the case with SVG. It's vector based, so whatever the resolution you have, it will look good on screen on a 72 dpi resolution, and it will look good when you print it on a printer which has 600 dpi. Will be no problem at all. So that's the scalable part in the vectors. So how did 4D implement that? Well, there is the rendering engine inside 4D that actually takes care of the drawing. It's kind of a black box, you don't have that much control over it. There is the other part that consists of the commands that let you actually tell it what to do and tell it what to draw. And basically they come in two forms. They come in the form of a component, which is the SVG component, which has a lot of commands that help you draw the rectangles, draw the lines, draw basically everything you need and alterate it. And there is the XML way of doing it, which is well, a lot more elaborative, but it allows you a bit more control. So, the 4D SVG component. This is actually a screenshot I got from the documentation. I can actually skip to that. The SVG has a lot of commands. It has to do with attributes, also the drawing, even filters are there, the structure and definitions. So it's very elaborate and it's very easy to actually use it and to get your drawings going. Okay, so basically to give you an example, to draw a rectangle, this is actually all it takes. Can everybody read that? Because it seems a bit small from here. So there's a line here where it basically just says new rectangle, and then it allows you to enter the coordinates and the things you would like to do. The second way of actually drawing or creating the SVG is using the XML dump commands, because the SVG drawing on your form is actually two components. There is the picture, it's a picture variable that's on your form, and there is actually the XML that is behind that picture variable. So 4D will render the picture variable and actually a picture type variable, but behind that is the XML, which is basically a large text that is SVG. And those two go together, and that is decisive for what you get on the screen. So with the XML dump commands, you can do likewise. You can build that XML text that is behind the picture, and the last command that is always issued before displaying is export to picture. So 4D will then take the XML and translate it into a picture variable that can be shown on the form. Now here you see, for creating a simple rectangle, these are the differences. The left one is with the SVG component. The middle one is actually doing the XML, creating the XML element, and setting all the attributes. So it's basically a lot more work to do it that way, but you have more control in the end. Now interestingly, there is a third set of SVG commands that are comprised of, let me count, six commands that actually deal with what is on screen. So what I use it for in the application I built is to have a rapid response from 4D and from the picture in a reaction in whatever I do. When I move the mouse over it, when I click something, it actually uses these commands to find out what object I'm dealing with on the SVG and what I want to do with it. It will become clearer later. So this is actually the XML that is SVG. So you see it's a lot of text. I can try and zoom in a bit, but see, it's basically structured that way. Just a kind of an FYI. Okay, so basically there are only two distinctive ways to display SVG with 4D. One is in list form or list boxes, and basically on the fly, as it draws the list box or as it draws the list form, 4D will actually render that picture for every line it displays in the form event on display detail. So to give you an example, it will do things like this. Now this is just a list box with three arrays in it. One is the Boolean array that shows you the checkboxes. Second one is a text array. And the third one is actually a picture array where the pictures are rendered on the fly. Another example is something like this, where you have a simple bar chart in a list box where the middle one is the picture array that gets drawn on the fly. And you can even do things like this, where every array element in the list box actually shows 3 bars. Why not? It's a picture, and you can draw basically anything you like on the fly, and it is very, very fast. So okay, these 3 things actually Same code to do that. How is that done? Well, we only need one form event that's on display detail. And in the on display detail, this is what gets done. The SVG new, just defining the XML that is actually behind it. We do a case off in just to decide whether to put a circle there or to put the big R there, which is the text. And last thing we do is export to picture, which is the command to actually translate the XML and the SVG to the picture array that is there. That's the only thing that's done to display that in a list. Okay, a second one is in input forms. And in input forms, this is an example of a chart in there, or something I developed over the last year is to actually allow the user to draw maps inside 4D, where it can place components and loggers and stuff like that. So these are typically the things we do in the input forms. So typically what you do is on the onload form, you will actually build the SVG. It's always the same. I'm using the commands from the SVG component. And SVG new is what you start with to define your canvas, to define the sizes of it, and it's basically it. And then afterwards, draw your rectangles, draw your circles, draw the ellipses, the lines, whatever you need to do inside the SVG. Now, one interesting thing is here, what I needed to do, because there was a lot of data we were dealing with, just to give you an idea, for making the chart, the charts, we had something like 100,000 to 200,000 data points that needed to be visualized. So you need to optimize the code a little bit in order to do that. And this is one very handy command. It allows you to draw a polyline by using arrays. So basically what it does is it populates the arrays, puts all the values there, and then with one command, SVG new polyline by arrays, we actually tell it to make the SVG for all those coordinates, all those points where you want your line to be drawn. Same thing, the almost last command, export to picture, which basically translates the SVG again to the picture that is on your form. And then you get something like this. Now, here, interestingly, are a number of SVG pictures, and there are actually more than 40. So one is the big one with the charts. The other one is on the bottom, which is basically the range slider component, which was also in a technical note. This one allows you to actually scale the picture that is above it. And then the other, I think, 30 or 40 are the pictures that are the colored square, the colored circles, and the R. Well, that's not an R there. That's the count on that. So here you see another example, but at the bottom we actually scaled the range slider a little bit, so to zoom in on a part of the chart. I'll demo that later on too. So that's displaying the SVG on screen, either on the list boxes in the list or in an input form. The thing you want to do is interact with the data. And there are not so many options to do that, but they're really useful and to the point. One way to interact with it is with the SVG commands that I've shown you, the 5 or 6 that were separate. It allows you to find out which element in the SVG you're hovering over. And what you need to know in the SVG structure is that everything you see on the screen and everything that is drawn is basically an object in the SVG that is defined It's actually an XML element, and you have an XML element for every line, for every piece of text, for every polyline. You know what it is. And the command SVG find element ID by coordinates will give you back the element where the cursor is over, if you give them the coordinates. And that is the only way to find out which element you're dealing with. So you know what it is that's sitting there, and it gives you basically an object name from that element, and if you keep track of that name, you will know by finding in your data or by doing queries what exactly it is you are hovering over. Now the mouse coordinates that I provide to the command, I prefer to use mouse X and mouse Y. These are actually 4D variables that are provided to you once you're in the form. And they're always correct when dealing with a picture variable that is actually populated by an SVG. They always match, and you don't have to convert anything. Unless you're doing scaling in the SVG, that's another thing that you need to keep that into account. But in normal situations, mouse X, mouse Y, there's nothing else you need to do. And you can use that and pass that to the SVG command. So that's what we do to know where the cursor is. Another way of doing it would be to actually run the on-timer event and make it go as fast as you can. And then in every on-timer event, check where the mouse is. That's also a way of doing it, but since it actually only makes sense when you're moving the mouse, then the mouse move is, I think it's a better command to use. So, how do we use that in that application? Well, we use that actually for every line there is, because every chart is a polyline that is filled out of, I think in this case it will be 12,000 or 15,000 data points per line. So every line is an element, and when you hover over it, in this case I use that information to highlight the red circle above it and to highlight that specific point on that chart and display the name of the logger, the data that comes with it. Now, what you have to remember is in dealing with the SVG and interacting with it, that there are basically no boundaries. You can do whatever you want, but you need to do every single thing yourself. There's nothing that 4D will do for you. It's because it's your own creation, the SVG. You create a world where you have lines or areas or text or whatever, but you need to tell it what to do every little step. I'll explain later a little bit more in the demo. Another thing is you need to track in your form event the mouse move, the on-clicked, and there is also an on-mouse up event. Now, why is that important, the on-mouse up? Because actually previously to that, there was no command in 4D that allowed you to trigger when you released the mouse button. Now, when you draw something on a map, it's important. If you draw a rectangle and you want to be that big, the moment you release, you need to detect that. And luckily, it's not that very much not that long since that command is there, but you need it so you know at one point it has to stop drawing the rectangle. And then you can do things like that, you know, select a whole bunch of points and having displayed information. That's the third application I've had for it, was actually drawing the map, drawing the areas, having them have a color, having them have a border, use the transparency and all things like that. This also can be done within SVG. Okay, the application we built over the last year we've called TMAP, and it's actually an application that tracks temperature management by reading in the data from temperature loggers. So basically, these things are used by people who need to track the temperatures in their freezers or in their warehouses. Whatever needs to be controlled, there are a lot of temperature loggers, and these loggers actually measure the temperature, for instance, every 5 seconds or every minute, and will keep that in memory until they're read into the application. Okay, so let me switch here. Okay, I had a few readings prepared. I'm gonna just use the big import, and then also to give you an idea how long it takes to read that. Now, this one has 12,000 points, but it's basically just one area on the map, and the map has like 5 areas. So I'm gonna switch them on. You see immediately how many points he has, if that's readable. So it was 160,000. This is compiled, and this is for the moment the best I can do, speed-wise, to get everything displayed. So it's fairly acceptable. Now, so that is what I wanted to show you. The hovering and the detection is actually on mouse move. So every time I move the mouse, it will go through the form method, and it will get in that event and actually query the data, what point we are hovering over. And you see, it's very, very fast. Despite having lots of data in it, the reaction is it's just instantaneous. See? Another thing is, whenever you're hovering over and you click, you can display data. You can do a query for that point. Now it's the table that has the data. I think for this one has 160,000 records in it. So it just does the query in that. And, 4D is actually fast enough to retrieve that within a reasonable time. So it gets that point, it gets the information that comes with it. You can even say, okay, this point is actually not correct. I'm going to exclude it, going to put some explanation in it, and that's it. So these are one of the nicer things you can do with it. Another thing is you can have an interaction between the list you have here and the chart you have here. So this is all controllable. I'm gonna hide the lines a bit so it's clear. So see, the moment I actually click one, or I go through the list with the arrow keys, it can translate that to the SVG and do something. Now, I said before, there's a lot you can do, but every little step you have to take it yourself. So basically what happens when I change the selection here and go through the elements is basically that it goes to find out what XML element is for that specific logger, because that name is in the XML file, that is the SVG. It finds the object, and then it will tell the SVG to change the attributes of that specific line and to change its width from, I think, from 1 pixel to 5 pixel. That's what it does every time I do this. And it's the same thing, and always recurrent. It's actually the same action over and over again, but that's important to know. It goes through the for method every time on the mouse move or on the timer that you have set, and every time it picks up an element by the find element by coordinates, it will exactly do that. It will find out which object it is, and it will change its attributes. That's how you deal with actually highlighting the lines and doing things like that. Another thing, for instance, is I needed to put markers on the chart, because the customer wanted to say, okay, I want to put a marker there because I did a power off of the refrigerator, or we had a power fail, and I want to have that documented on the chart. So that's another thing you can do. Now this one is using the on timer event also. It's not only the on mouse move, it's also the on timer, and it allows me by just holding down the Alt key to do something like that. So it picks it up in the on timer. It sees, oh, Alt key is pressed. I guess he wants to add a marker, and that's exactly what I want to do. So you see, as long as I keep this Alt key pressed and I move the mouse, the combination of those two events, it will actually draw a line, put the date there, put the time information there, and change my cursor to a plus, so the user has an idea, well, okay, I expect you to do something here. So as soon as I reach the Alt, it disappears. See, so that's the on timer event that actually does that. Now, third event we use here is the on clicked. As soon as I click, then it knows, okay, I have the coordinates, I know what I need to do, so I need to add a marker here, and I'm going to ask the user what exactly it is that he wants to do. So in this application I can select different kind of markers, for instance a steady state or a power fail or a door open close. That's all events that are likely to happen in this charting event. So let me just fill that out and accept it. So what it does now, I selected the door open event, and he knows that there are 4 markers in this case that he needs to put on there, so the user can do that. So here, see, it's the same trick we're using over and over again. So this is on the on mouse move, and as soon as I'm getting over this XML element, which he knows is a marker line, then I've coded that he needs to make an indication so that that is selected and I can do something with it, because as soon as I click and I move, then he needs to display the timer again, so I know at exactly what point I want to drop that line. See? And interestingly enough, these are always the same commands. So the routine is very easy. Of course, filling it out and working it out that everything works as you should, well, you know, that takes quite some time and quite some coding to draw the lines, to move the lines, to move their attributes. But the principle is actually always the same. So that's about the charts. Now let me show you the map that goes with it. This is another SVG feature where you can basically tell it to change its scale. So you can zoom in, zoom out, use the scroll bars and stuff like that. Now this is basically the standard drawing program. You can move things around. Oh, that didn't go too well, apparently. You can move things around, you can resize them. You see the little circles and markers that are there. See? And when you resize, then it grows, and then it shrinks with you, it moves things around. Now again, and I didn't build this completely myself. This is also a technical note. It's called SVG area. And it doesn't use the SVG component that is inside 4D. This one actually does all the building of the SVG by using the XML dump commands. So to be honest, it took me a while to figure it out how exactly it worked with all the code that's in there. So this is kind of a difficult one to understand. But just to give you an idea, if you see the ellipse here, by actually resizing that, now let me tell you what it does. First of all, it will change the attributes of the ellipse, which is basically easy. It will change its width, it will change its height, and that's it, you're done. And with the SVG commands that can redraw the screen very, very fast, this reacts immediately. Now the other thing you need to do is, you see the circles on the corners and midway, well, you have to move them as you resize. So every time I have the on mouse move event, it will actually resize all those circles, it will resize the ellipse that's there, and it will move the rectangles in the middle where the blue color is for the indication of the temperature and the name of the area. It will move that also. So that's quite a lot of XML handling it does right there by just moving things around here. But you see, it actually follows quite nicely. And even things like that, you know, these are the symbols for the loggers that are composed of a lot of elements. There's the cross, but these are actually two lines, one horizontal, one vertical. There is a rectangle that is drawn. There's a second rectangle inside. There's a number. There are the labels that are colored. I don't know if you can tell, but there are these little icons here, things like that, that also need to be drawn. So it's a lot of things that need to be drawn, and let me just, okay, sometimes some disappear, so it's not fully debugged, but let me oh, wait a minute, it's easier to actually select a whole bunch. So even if I move that around, you know, it just follows me. And actually this is easier than the resizing, because it just has to change the coordinate attributes. So basically there's an X and Y attribute for every XML element in that selection, and it just has to change the X and the Y. So it goes very fast, see, and follows you around. Okay.
Rudy, what are those objects? Are those pictures? Or?
No. There's not a single picture in it, although you can add pictures to the SVG. It's not a problem at all. With the picture, it is like it is. And with the picture, you have the resolution of your picture. It can be big, it can be small. So for printing, you would need a bigger one if you're printing high resolution. But we chose not to put pictures in place, but actually draw all the objects that are there. So if you look at this logger icon here, for example, this one is completely drawn within the SVG. There are no pictures involved. So even the little temperature icon here, there is another. Hold on, there is another one here. Let me just switch that on for you. There are these droplets which actually indicate there's a sensor for humidity also. So all these things are drawn. Even the droplet I've drawn in SVG. So it takes some work to actually draw the path, but in SVG you can draw something from point A to point B in a straight line, or you can tell it to curve a little bit. So if you combine that, and you combine the curve and then with an arc, which is also an SVG command, and the other curving in the opposite direction, you get the droplet form. So that's how I did that one. And in SVG you can basically draw that one time, that element, and then use it over and over and over again in every other object, because the SVG is structured and is actually XML, so you can have child objects and child elements inside the XML. So it's very extensive, and the SVG itself it's quite powerful in what you can do with it. So, but just to give you an idea of what the possibilities are. Another easy one, for instance, is the transparency of the colors. Let me just set the fill color here. Oh no, wait a minute, that's gradient. I'll just give him a color. Now that's full 100% opacity, but you can just tone it down a little bit, see? And it gets transparent. And you can do that for every object that is there, and for basically everything that comes to mind. And you think your imagination is kind of the limit there of what you can do. But you have to think about the process and do every little step. Even moving something is changing its attributes every time. So that's about it. The last thing I wanted to show you is something that seemed quite nice in the context of this application, but I need to make sure you see the chart behind it. Okay, there it is. So here I changed the view where it doesn't display the names of the serial numbers of the loggers, but it actually displays the temperature. And as you move through time, it will actually show you in colors. Wait a minute, start. Okay, there you go. It shows you in colors how the temperatures evolve over time. And there's actually an interaction between the one SVG in the one window, which is one process, and the map that is in another process. And they just talk to each other and they update the SVG accordingly. So, that's about it. Any questions?
Very impressive. Have you noticed any limits on speed with the 4D's SVG rendering engine? Had not you doing the computation for the SVG, but just so many SVG elements that it takes time to render. Have you run into any limits like that?
Yeah, there was one chart I tried, and it had 500,000 data points. So basically, in the application, it translates to 500,000 records, because every data point is one record, and there's no other way of dealing with it. So he needs to read that, and the reading, as you saw, it's quite fast. It's something like maybe 20,000 data points per second, something like that. So it's very acceptable, but yes, it tends to get a little slow, and it's not, you know, the SVG is not the problem. It's the data handling behind it, because when you saw when I moved over, hold on, I'll show that again. When I move over the data here, see, it goes very fast, and it has the data very fast. So these are 200,000 data points that are on an SVG.
You're using the changing the attributes that with.
Yeah, what I do here is when it comes over this polyline, for instance, then that is an XML element. It has an object name. So by the command SVG find element by coordinates, I get the object name, and by that object name I know in my data which record it is, and I'm going to find it. Now, to be honest, I needed to do some more tricks to make it go that fast, because if I just leave the data there, which are 200,000 records in the table, it has to query through. If I just do that and I query through it, then it's not fast enough. So what I needed to do was actually for every polyline, so for every charted line there is actually a set that I created of the data points. And as soon as he selects one of the lines, he will get that set. And when he does a query, he will use that set first and do a query in that. And that's a lot faster. So it's not the SVG per se that is slow, because the SVG is actually very, very fast.
Well, I have run into limits. For that particular thing, what I've done is had an attribute for the line that then I'll change the width of the line on.
That's what it does, yeah.
Okay.
Yeah.
But I don't have to do any computation. I can use the SVG's attribute. It is just time consuming.
Yeah.
But I ran into limits where I had 5,000 or 10,000 objects on a drawing with drop shadows, and there was a noticeable lag for that SVG to be rendered with a drop shadow.
I can imagine, yes. I can imagine with the drop shadow.
Cool effect, but users don't want to.
Oh yeah, there's another one also, because SVG allows you to do a lot of things. And for instance, if you have a polyline like that, which in this case is 12,000 data points for each line, you can actually tell the SVG to draw little circles on every point. Mm-hmm. And if you do that, then it makes it a lot slower too. So there's certainly in that amount of data that is displayed, there's some things, well, you better not do.
Have you run into you use some XML, but use mostly the SVG commands, it sounds like.
For the chart, yes, I think I used the SVG commands from the component. Mm-hmm. In the map, these are all pure XML DOM commands. So it actually goes changing the attributes of the elements. Mm-hmm. Basically, it does the same. It changes the XML that is behind the picture. And the only thing that is facilitated with the commands in the SVG component is it's more readable also, you know.
The limit I ran into was the SVG component generates very wordy XML, and to transmit that from server to host was noticeably slower than when I coded it using the equivalent XML. I just couldn't afford how large the XML became with the SVG component.
Well, to be honest, with the charts, I'm not saving the XML.
So the database transfer.
It's just the data.
It's all on the
And
fly.
as soon as I open this chart, it will actually read all the records and draw the SVG as it comes. With the map, it's different. With the map, I actually store the complete XML inside a blob in a record.
Okay.
But the map is not that big.
Very impressive.
Yeah. Thank you. Okay, thank you very much. Please provide feedback.